Dear students, good morning. Welcome to online class. Today say about light lesson. Today discussing topic is Snell's law of refraction and dispersion. Snell's law of refraction. Refraction of light rays as they travel from one medium to another medium, and lights obey two laws which are known as Snell's law of refraction. So these two laws are, first one law, the incident ray and the refracted ray, the normal at the point of intersection, all lie in the same plane. Incident ray, refracted ray and the normal at the point of intersection all lie in the same plane. First law. And then second one law, the ratio of the sine of angle of incident I to the sine of angle of refraction R is equal to the refractive index of the medium. So refractive index is a constant. Refractive index is a constant. So Snell's law are represented by sin I by sin R equal to mu. So sin I divided by sin R equal to mu. Mu is the refractive index of the medium. Mu is the refractive index of the medium. Then I is the sine of angle of incident and R is the sine of angle of refracted rays. Okay students, see the image. This is the incident ray. At this point refract, then moves this way. So this is the incident ray and then this is the refracted ray. Okay students, so theta 1 is the angle of incident, then theta 2 is the angle of refraction. So second law is the angle of ratio between the angle of sine of incident to the sine of angle of refracted ray is equal to the refractive index of the medium mu. So sin I by sin R equal to mu. So this is the Snell's law of refraction. Okay students, first one law, this is the incident ray, then this is the refracted ray, and the point of intersection is this one. Point of intersection is this point. So intersection, incident ray, refracted ray or meet this point. So these three are all lie in the same plane. So this is the plane. So this plane above air medium and below liquid medium. So air medium is N1 and liquid medium is N2. Then sin Q1 divided by sin Q2 is equal to N2 by N1, and N1 and N2 are medium of the mediums. So air medium N1, then N2 is the liquid medium. Okay students, then dispersion. So this is one of the important one. So place a prism on the table and keep a white screen near it. So prism is a triangle shaped object. Prism allow light two side and the third one side not allow. Okay students, so place a prism on a table and keep white screen near it. Then With the help of torch, allow white light to pass through the prism. So allow white light through prism with the help of torch. Okay students, this is the experiment, dispersion experiment. So see the image clearly. So this is the prism. This is the prism. This is the white light. So white light passes through the prism. Then the white light refracted into 7 different colors. 7 different colors. So this phenomenon is the dispersion of light. Then another one prism inwardly another one prism placed inwardly on the table like this. Then allow the 7 different colors to the second one prism. So the second prism recombine the 7 different lights into a single white light. A single white light. So the 7 different colors passes through the inwardly placed prism. Inwardly placed prism. So the 7 colors are recombined to reflect on the other side to give a single white light. Okay students, then next one. So what do you see? So a white light passes through the prism. What you see? So can observe that white light split into 7 colored light rays, namely violet, indigo, blue, green, yellow, orange and red on the screen. So white screen visible the 7 colors. So shortly the 7 colors named as visual: violet, indigo, blue, green, yellow, orange and red. Now place another one prism in its inverted position between the first prism and the screen. So already discussed. Now what do you observe on the screen? You can observe that white light is coming out of the second prism. So the second prism recombine the all 7 colors and coming out a single white light. Okay, so observe the white light is coming out of the prism. Okay students, then next one. The first prism split the white light into 7 colored light rays and the second prism recombine them into white light. Second prism recombine the 7 different colors into white light again. So it is concluded that white light consists of 7 colors. White light consists of 7 colors. Then another one, definition of dispersion of light. So splitting of white light into its splitting of white light into its 7 constituent colors on passing through a transparent medium is known as dispersion of light. So it is the one of the important question. Dispersion of light. Define dispersion of light. So splitting of white light into its 7 constituent color on passing through a transparent medium is known as dispersion of light. Then why dispersion occur? So what reason a white light refracted into 7 different colors? Why does the dispersion occur? So it is because light of different colors present in the white light have different wavelength and the different colors travel at different speed in a medium. So different colors. So 7 different colors present in the white light and these 7 different colors have different wavelength and these 7 different colors travel different speed in a medium. Different speed in a medium. Okay students, the next one. So as each color light has different speed and the constituent colored light are refracted at a different extent inside the prism. So VIBGR. So violet color is refracted at a top side and red color is refracted at a bottom of the color. So top side violet, bottom side red, VIBGR. So it is concluded that refraction of a light rays is inversely proportional to its wavelength. Inversely proportional to its wavelength. So refraction of light ray is inversely proportional to its wavelength. Then red color light. The red colored light which has a large wavelength is deviated less, while the violet colored light which has a short wavelength and is deviated more. So it is concluded that shorter wavelength deviated more, but longer wavelength deviated less. So red color light, large wavelength, deviated less, but the violet color light, shorter wavelength, but is deviated more. So shorter wavelength deviate more, large wavelength deviate less. So red color light, large wavelength, deviated less, but violet color light, shorter wavelength, but deviated more. So it is the one of the important one. So this is the reason for red color light placed at the in railway tracks. So red color light, longer wavelength, so long distance clearly people seen. Then next one important topic students, rainbow. We are enjoy rainbow in rainy season. So the formation of rainbow is an example of dispersion of light, dispersion of white light, dispersion of white light. Then next one students, so the rainbow can seen on the opposite side of the sun. So the rainbow seen on the opposite side of the sun. So we are watching rainbow in rainy season students. So after rainfall, the large number of droplets still remain suspended in the air. Large number of droplets still remains suspended in the air. So large number of droplets are present in the atmospheric air after rainfall. Then when white light passes through them, when white light passes through the droplet of water, the white light is split into 7 colors. The white light is split into 7 colors. Dispersion of white light from a large number of droplets eventually forms a rainbow. So dispersion of white light from a large number of water droplets eventually form a rainbow. Students, consider this. This is the water droplets. Students, consider this is the water droplets in the atmospheric air. So this is the incident ray from sunlight. So the incident light refracted in the water droplets refracted into 7 different colors at different angle. 7 different wavelength, different color are refracted when a white light passes through a droplet of water. So a number of droplet reflect number of refractions. So we see a rainbow. Okay students, thank you students.